Howdy, everybody. We're back here for day 4 of the Advent of Code. We've done days 1 through 3 in Rust and a couple of them in Haskell. Hopefully we can get back to doing it in Haskell again. But before we move on to day 4, I just want to do a quick introduction to nom. So I was talking to someone. Let me see if I can find the actual thing in the video. I had asked, is there any equivalent of like parsec for Rust or other languages? Because they're pretty cool, right? If you think about the way that they do the combinator parsers. I had implemented a parser in my compilers class, whatever, 25 plus years ago, but I had never done it in, done anything more than that. And so these parser combinators are pretty cool. And it's Zomakia. He said that there was a library called nom. And so I looked it up, and there's actually, you can go to this, I'll give you the link for it, but you can go to this page and it gives you kind of an introduction to what nom does. And you can think of it as like parsec for Rust, which is pretty cool. So you do same thing you do like composition, like you do in the parsec, right? So if you're trying to parse like an integer pair, you do this like separated pair, and you do this to get like the pair, right? And then you can chain those together. So if you're parsing a coordinate and you have a pair that's surrounded by brackets, you can do a delimited thing like that. Anyway, if you use, you can read through this, the nom guide. I think it only took me 20 or 30 minutes to look through it, and maybe another 15 or 20 to like test out the examples and stuff like that. But if you do look at it, let me just go back to day 2 really quick. You can make changes like this. So whereas first I was doing like a split by white space and then iterate over that and unwrap, you can just do things like this where if you remember, the input looks like this, and you have like a game, and each game has has some number of rounds, and each round has some number of tiles or blocks that were pulled out. So in this round there were 19 blue and 12 red pulled out, and in this one there were 19 blue, 2 green, and 1 red that were pulled out. And so you just basically build your logic around those pieces, like you would in parsec. I think I had shown before that you can do it in parsec. But so you do like for the colors for each piece of the round, you just do a separated pair, and you say, I want it's a U64 split by space, and then there's an alpha numeric number, right? And then when I parse a round, I create this parse function for the round. I just say within each round, there are colors that are separated in a separated list, separated by commas. And so you call this separated list 0, parsing or separating it by this. And for each of those chunks, you call round color on it. And just like parsec, nom is smart enough to figure out that, I'm going to go and find as many of those I can and return those colors. I still, just like parsec, had to do a bit of color matching, right? Because I'm using a struct of red, green, and blue. And so in order to go from the various colors, some of which may be 0 or may not be in the round, I can just iterate over all the colors that that nom found, and set those values as they come in, and then I return the round. And then you do the same thing for the games, right? If I want to parse a game, I can just say, the game has a game tag. A tag is like a way of saying just a chunk of text, a string. And then it has an ID, and then it has a colon and a space, right? So that's the beginning of the game right here. It's saying this is the first part of it, and it will pull out this U64 for me, and I can like put that into the ID. And then I just say after that, the rest of the game is just a separated list of rounds that I can call that parser that I showed above. that are separated by this semicolon. So it's really easy now to just, so what nom will do then is look at the input, it will extract this ID, and then it will get to like this position right here, and then it will call parse around for each of the separated lists that are separated sections by this semicolon. And then if I want to do all of them, right, obviously I could call this parse on each line. I could call the lines function and then call this parse. Alternatively, I just call this parse all function that where you can take the whole input stream and it gives you a vec of games, and you just say, oh, well, each game is just separated by a new line. So you use the separated list 0, and then it will parse all of them for you. You do the unwrap to handle the error checking, right? This I result is like a nom result where it returns what it parsed and what it didn't and any possible errors that may be associated with it. And then, so the actual value of all the games or each game is in the 1th tuple, the first part of the tuple. So you do the -1 to get it. And then otherwise it looks the same. You just run it, but I think this is kind of a cool way of parsing structured input. And maybe today I did look, today we will be able to use it. I read through the thing briefly, but we'll read it again. But this is something that you could potentially use in your Advent of Code or just any structured parsing. Most of the things like leak code and stuff like that don't really have structured parsing. But there's other places where you do game challenges like this, where you want to parse some kind of input and handle the thing. And so anyway, I thought it's a cool thing. So again, thanks to Zamakaha for letting me know about this. And as always, like I welcome your guys' input, and I welcome comments and thoughts, and I'd love to see the stuff that you're doing. So just, let me know in the comments, and if there's other cool things that you guys are doing, and we can talk about that stuff as well. But given that, let's go to day 4, see how far we can get on it. Okay, so if you remember, we finally fixed the gondola, and now the gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of a new island and lurches into the station. Okay, we're on a new island. As you exit the gondola, the first thing you notice is that the air here is much warmer than it is on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful squares. Oh, hello. The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though this is Island after all. I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Okay. I guess I thought I read it this morning. Maybe I didn't read this closely. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque coverings already scratched off. Picking one up, it looks like the scratch card has 2 lists of numbers separated by a vertical bar. A list of winning numbers and then a list of numbers you have. You organize the information into a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first, doubles the point value of that card. For example, okay, we got it. In the example 1, card 1 has 5 winning numbers, 41, 48, and 8 numbers you have. Of the numbers you have, 4 of them are winning numbers. So these are the winning numbers, and you have 4 of them: 83, 48, 17. What's the 86 is the other one. Yeah. So these are the winning numbers, and these are yours. That means card 1 is worth 8 points. 1, 2, 4, 8. Double it each time. Card 2 has 2, so it's worth 2. Card 3 has 2. Card 4 has 1. 5 and 6 have none. The else pile of scratch card is worth 13 points. Take a seat in the large pile of colorful colors. How many points are there in your total? Okay, so basically we have, again, we'll be able to parse this input with nom, I think. But we have a set of winning numbers, and then we have a set of our numbers. And we want to find out which ones, how many of ours are winning, and however many there are the number, we double that many, we double it that many times. And then we just sum up all the wins. 8, 9, 10, 11, 12, 13. Yeah. So it feels to me like, again, we'll do a lot of parsing, but we can potentially just do some set stuff. So if we presume that this set is the set of winning cards, and this is the set of winning numbers, and this is the set of our numbers, if we do an intersection of the two, we will find how many are correct, and then we can probably do some bitwise logic to increase those. That feels like it would work. The one... Yeah, I don't see why we can't just do an intersection of sets. Like, the one thing that's going through my mind, is there any case where you'd have like multiple winning numbers in the thing? I don't know. We'll see. Maybe I won't get it correct the first time. But that, because you could potentially, it might be easier just to do a sort of the two lists and do a check. But I don't know. The set seems easiest, like logically, and at least code wise. I won't have to do much iterating on anything like that. So that's kind of what I want to try first, is do some set stuff and do some intersection. So we'll get, each card will have 2 sets associated with it and an ID. We'll want to parse that, and then we'll put it all in here. Okay, so let's get our puzzle input, and let's get started. Interesting that it has some double spaces all over there. I wonder if that's, plus it's got extra spaces right here. I wonder how that will affect the parser. We'll find out. You're going to figure it out with me. But so let's just start out with some types. What do we have? We'll want a set. So use standard collections, close, a hash set. Do I need it? Maybe I'll zoom this in a little bit more. So we have a card, which will have an ID. Just make it a U size, and then we'll have the winners, which will be a hash set, and then we'll have the picked. What do they call it in here? Picked numbers, or hours. It's going to be a hash set of U size. So let's try and use nom to parse this. It might figure it out for me. That's why I was thinking of, do I need to import the nom stuff? But if I impl card and I do an fn parse with a and I return an I result of like that. It tried to do it for me, but let's see. So what do we want to do first is we want to get the ID. So we'll say let input ID is equal to num I guess I can just go back to day 2. What does day 2? Delimited. There could be multiple spaces. How does the delimited one work? First, second, third. I may not want to do this yet. If I just do let input, yeah, like that, and do that. And there's a way to do multi, so maybe if we go to this thing and say repeating parsers. No, we want to look at the composition. Not alt. Not pair, delimited. Part of me is tempted just to do a regex to remove all the extra spaces, but let's try and do it in... I mean, I guess I can do it like this and just say let input equal what are there's like a character class called alpha, but we want to do it by white space. So let's see, what are the other character classes in here? Space. Yo, that was not right. Space 0. So that will get rid of all the spaces. And then we say let input ID equals get this, and then do that. So this looks a little weird. I wonder if there's a way to, like, there's got to be an and thing, or like a... the composition. So there's the alt, but the alt is like either or. So it will either pass, it'll either do ABC or DEF. Execute each parser in a tuple until it finds one that does not error. If all error, then it returns an error. Yeah, so it's not alt. Simplest way to do composition is to evaluate them in a sequence. Yeah, so this is what I was doing right here. Oh, it is tuple. So will that work if we do let input ID equal tuple tag game space 0, like that? Oh, I've been doing this in the wrong thing. That's funny. Let's go back to day 4. Okay, here we are. Okay. So that should give us the... Oh, but it's called card now. So there's card, some number of spaces, possibly only one, then the ID, then the thing, or then the colon. And then after that, we have our 2 maps. So we should create like a parse map function that does it by any number of spaces. So we can do like a fn parse set with a string, and it's going to return a hash set. And we do, we say like, let input nums equal, there's like a separated by, take till, take into, nope, this is not it. So maybe it's repeating with predicates. Nope. Repeating parsers. Where is that? That's funny. Why can't I not see it anymore? There was a separated by. Count mini 0. Oh, separated list. That's what it was. So they're going to be separated by spaces, and we're looking for numbers. So we do separated list. Wow, why does it keep doing that? That's funny. It's Emacs, it's not. And it's going to be by space 0, and it'll be a U64, and then we'll just collect them all and return them. So I don't know that we have to do this. We just do okay, like that. It's okay, and then it's a tuple of the rest. Like nom always returns what's left in this thing. Add missing generic. What was this? An I result. I must be doing this wrong, this part wrong. Again, somehow we're spending a lot of time on parsing. But I think the solution will be pretty easy once we get there. I result. Yeah, that seems right. Oh, I'm providing a tuple, but it should just be like this. So we just say let input winners equal oh, I can do both of them. Like there's a like a separated by. I swear there is. Well, I could still do separate list, and then I would get both of them. Or I could just do another tuple. So we could say like let winners r's equal to sorry, not a no, it would be a what do they call it? They did it in the custom outputs is where they did it. Right here they did a thing like this, and it's separated pair. Yeah, there we go. Separated pair. And so it would be a parse set separated by this, and then another parse set on on. It's really annoying when it does that, huh? Okay. Oh, okay, but it did figure it out. So we do a separated pair for to get the winners and ours, and then we just take the ID. Let's see what it's missing. Expected a closure. Found stir. Oh, it can't find parse set. It's tag. I need to wrap this in a tag. And I misspelled card. Okay. Cannot cast primitive stir U64. Oh, because I'm doing a tuple, it's got all four of these. So I do something like this. If I add the correct number of parentheses. Okay, we're compiling. So now let's add a parse all, and we'll just do the same thing. So we say fn parse all, and we'll just get we'll do the same thing where we just return a vec self, and then we'll fix the we'll just do the parsing here and return it and unwrap it. So we say like let input cards equals separated list, not a double new line, but a single new line. And we call card.parse, then we unwrap, and then we return. Oh, I can actually just do it like this then, huh? .1, just return the first value of it. So down here now, we should be able to say, that was a lot of work, but I presume now we just can go like this and read to string. And now we have all the cards, and we can do something like, well, let's just print them first. So we need to derive debug. Yikes. No cards. Okay, so we don't quite have it yet. Let's look at the input and see what we got. Card, some number of spaces. Maybe we just test it on a single card. So if we do like from dot, that won't be it, but we'll just card. We'll do card dot parse unwrap one. Yeah. Oh, it's not dot dot. It's not dot. From apparently I was doing some Go coding today. Separated list line 50. Okay, so this apparently is failing the parse, is what that's saying. Error input separated list. So there's something about the separated list that's causing an issue. So let's look. What are we calling separated pair? It's right here. Separated list. We're not doing it on that one. We are doing it on this one though. Parse set. Separated list. Okay, so we can just try and call that directly right here. We can say presumably it will look like this. And it is on that. So there's something about that parse set function that's wrong. Tag comma. AB, AB, AB. Separated list is an FN mute I, result I. The separator is G, which is a parser. IO to E. I mean, is there like a space one function I should try and use here? There is no space one. That's weird that it doesn't work. Again, we'll have spent most of our time figuring out nom, which I guess is helpful, because I do think it's a cool thing. Like, what my thinking is I want to be able to, like, parse any number of things separated by spaces. $52. Okay, input. Nom character complete U64. That's the number. We want to do a bunch of numbers separated by space. I mean, I could just, what if for right now we just do tag space like this? Does that work? Yes, it does. Does it work if I do this? No, it doesn't. See, it only finds the first one and then it thinks, oh, I'm done. And like, that's the issue. If you look at the input, like this number 3 here is going to have an extra space. So I want to tell parser IO2E separated list tag ABC of input. ABC returns all of them. ABC 1 to 3 returns ABC, ABCDF. Okay, maybe is there some other, am I missing a character class? 0 or more spaces and tabs. Space 1 does the same. Oh, that works. Was I using a different like space 1 or something like that? That's really weird. Okay, let's just make sure, like with the first one, 1373, 35. Oh, it's going to be a hash set, so it'll be in weird order. But we can eyeball it. 73, 13, there is 39 in there, yes. 82 and 2 is in our picks. Is that correct? Yes. Okay. So I think we got that part right. So now we have all the cards. Again, how long did we spend doing this? 30 minutes on parsing. Okay, so it might have been faster just to split this up, but I wanted to try and use nom. You can tell me how well I did or how well I didn't do. So now we just need to, we want to do the intersection, and then we want to multiply those together. Or sorry, not multiply them, double it for each one that won. So I believe like, actually let's just do this. 4. Will that produce 8? Oh, am I going the wrong way? 16. Oh, yeah, because I'm moving. The first game is only worth 1 point, so I'm going to do like n minus 1. So it will be something like let count or let we're going to do it for each card. So we're going to do let p1 equal to cards dot iter dot map c we'll create a function called like winner and we'll sum over it. So we need to create a winner function here. Is going to be let count equal, or let wins equal like that. And then we return if wins equals 0, we return 0. Else we return wins minus 1. Yeah, there we go. I got it. So far we haven't used the IDE, but maybe that's okay. And then we just right here we'll print P1. That seems kind of low. We're summing up all the winners, and the winners each time you win 1, 2, 4, 8, 16. How many inputs were there? 200 and 2. That feels really low. So I want to try it on the test input then first, just to make sure I'm not missing anything. Let's get that and make sure we're getting the right solution to it. What did they say the solution was? 13. Yeah, that's not right. What if in here we print it out? We say print line c.id and c.winner. See which one we're missing. So we only count games 1 and 2. We don't count three or 4. 3 has 1 and 21. 1 and 21. Whoa, whoa, whoa. Oh, we're missing some of them. Cards iter map. Because it should count all of them, even if they're 0. right? There should be 6 of them. So what's wrong here? If we print line cards, we only have 1 and 2. So parse all, separated list 0. Oh, it's this space 1 I need to do as well. That still only gets me 2. Separated pair. Oh, it could be any number of spaces between here. Man. For some reason, it's not finding the 3rd card. And so it's never adding it. Is that right? Am I thinking about that right? It's adding card 1 and card 2, but not card 3. It only sees these 2. Interesting. So potentially what I could do is, I don't know why that's not working, but instead of doing that, I could say we could do input.lines.map L card dot parse L dot unwrap dot 1. Does it have anything to do with the well, now we'll at least get this error. We panic where 57, yeah. Which one of our iterators are though? 59 is here. It unwinds funny. Why am I not seeing? I mean, I know it's on the unwrap, but why is that? Oh, it starts with a space. Bully. Okay. So we need to be cognizant of there being more than one space here. So what I kind of just want to do is do this and then do space 1. There we go. Okay, so I can probably now go back to card.parseAll. I don't need this. I can just call that Okay, we got 13. So we're still missing something. I'm almost sure there's not. Let's just count cards.link. There's only 11 of them. So this is one of those things, right? Oh, yeah, so this is the one that there's a space after it, which can also be a problem. If you've been using nom more than me, I would very much be interested in knowing how you would parse something like this, because this feels a little weird saying in one or more spaces, but I mean, I guess that's what you do. So what does that mean? When we're doing the parse right here, instead of doing a tag, what if we did like a collection of them? So in it you can do composition, and you do, it's not alt, it's tuple. So if we do tuple here, space 1, tag, blah, space 1. Oh, I need to put them in an actual tuple. Nope, apparently not. Oh, I had an extra one there. Do I just need to, maybe there's something I'm missing about this tuple thing, and I just need to do it like a card parse pipe, and then we create a parse pipe function. Yeah, but it won't look like this. It'll look like, there we go, 202. Okay, so interesting. I'll have to figure that out. Why would I have to do a parse pipe for that tuple? Maybe that's just the way num works. Again, if you know more about it, I'd love to hear your input. But that does give us a better answer, I think. So let's try and turn it in and see what we get. Hey, we got it. Okay, so 95% of that was parsing again. I mean, again, I probably could have done it easier, but it was good to learn about nom. And hopefully you learned something about nom as you were doing this with me. But let's go ahead now and move on to part 2, and then we can do some refinement on our code and see where we get. Just you're about to report your findings to the elf. Just as you're about to report your findings to the elf, one of you realize that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So if card 10 were to have 5 winning numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10 and it has 5 matching numbers, it would win a copy of the same cards that the original card 10 won. Cards 11, 12, 13, 14, 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Okay, so card 1 had 4 matches, so you win 2, 3, 4, and 5. So now you have to iterate over 2, 3, 4, and 5. And your original card 2 has 2 matching numbers, so they would win 3 and 4. So now you win 3 and 4. Your copy of card 2 also wins 1 copy of each 3 and 4. Yeah, so we've won this one once, these 2 twice. Your 4 instances of card 3 have 2, so you now win 4 and 5. Oh, and because you've won 3 that many times, you won 4 that many more times. Your 8 instances of 4 have 1 matching number, so you win 8 copies of 5. Your 14 instances of 5, the original and the 13 copies have no matching number, so you win no more. And no more there. Once all the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of 3, 8 of 4, 14 of 5, and 1 of 6. In total, this example pile of scratch cards has caused you to ultimately have 30 scratch cards. So you get 14, 15, 16, 17, 18, 19, 20, 21... 15, 21, plus 9 is 30. You'll only ever have 1 of card 1, but you could have multiple of the other cards. Process all the original and copy scratch cards until no more scratch cards are won, including the original set of scratch cards. How many scratch cards did you end up with? Okay, so this does feel like it's a counting problem, and we might just want to keep a map of each of the cards and how many times we won each of them, the default being 1. And then, like, how does that look? Like, when you hit 1 and there's 4, you now increment 2, 3, and 4. So now you have 2 of these. And then when you go to card 2, it has 2 matching numbers. And so you copy this, but because it already has 2, you copy this 2 times. And then you just kind of do this recursively. So you start at 1, increment, go to 2, multiply an increment, go to 3, multiply an increment, go to 4, multiply an increment. So you may have to do it iteratively, but that's the process that's going through my mind. He's kind of lined it out for you right here, right? Is if you start at card 1, you now increment 2, 3, 4, and 5 because you had 4 wins. And then, so this is now 2. There's now 2 of these. So when you process 2, you do 2 times however many. So your copy 2 has 2 wins, so you do 2 times 2, so you double this one and you double this one. And then card 3 has 2 matches as well. And because you've doubled this, you now have 4 copies, so you quadruple 4 and 5. And since it was already 2, quadrupling 4 makes it now 8. I think that's how it looks. We'll start with the test input and see how it looks, but that's how I'm tempted to solve it. It doesn't look like we actually use the ID. Nor space 0. Okay, we can clean up some of this stuff later. But now that we have all the cards, we can do a let mute counts equal like what is this? We want to start them all out at 1. And then we say for I in 0 to cards laying. We want to go back up to the winner function and do something slightly different. So fn winning count, we'll create a function called that. And it will just return this intersection. And so we can say we're going to start at 1 and go to cards I winning count. Is that right? So if it's 4, so this one has 4, so it's going to increment 2, 3, 4, 5. So you're going to go from 1 I actually think we want to go from 0 to cards winning count, and then we increment all of them plus 1. So for J in that, so for each of those, we want to say counts I plus J plus equals counts I. No, it's times equals. No, that's not right either. For this one, it's going to go from 1 to 2 because this one has a value of 1. We're going to add that value to it. But now that there's... so these are all going to go to 2. When this one runs, all of these are going to go to... the scratch card. I had to think about this for a second, sorry. You win copies of the scratch card below the winning card equal to the number of matches. So if 10 cards... So if card 10 were to have 5 matching numbers, you would win 1 copy each of 11, 12, 13, 14, 15. So if you win a copy of card 10 and it has 5 matching numbers, it would win and copy the same card that the original card 10 won. This process repeats. What it is I'll now have 2 card 2s. So when I'm on card 2, I want to add two to each of those to 3 and 4, right? So I add 2 to 3 and 4, and then I add another 2 to 3 and 4. So now I have 4 instances of card 3. So I win, and it, I add 4 copies of 4 and 5. So it is just summing them, right? For each count, I'm going to increment all of them of my current count. I'm going to increment this count by my current count's quantity. And I always start with at least one of them. And then I just go through all the cards and do that. It's possible that there's 0, so then I don't do any of them. Oh no, it's going to be, let's keep them counts. And let's just call it counts.iter.sum. Yikes, that feels like a lot, but your answer is too high. Okay. So let's think, what am I missing here? I know I always start with one of them, and then for each of the cards, from 0 to cards laying, for J from 0 to, +1, right? I have to wait 19 seconds. But I think that's it, because I don't want to increment myself. I want to increment all of them plus all of them past me. But I have to wait 19 seconds. Maybe while we're doing that, we can look at some of this code to see if there's some stuff we can do. Yeah, we don't use space 0. We don't ever actually use the ID either. So do we just ignore this ID? Makes me wonder if there's some kind of regex type pattern or something you could do here to, like, I mean, it feels like it should be a tuple, but maybe I'd be interested in any nom aficionados what would be different in that. But there you go. Basically, we're going to do the card, any number of spaces, the ID that we're not actually using, the tag, and then any number of spaces. And then what's left will be where we parse the 2 sets to get the winners in our own. So if we're creating a winning count function, we can do it right here. Just recall this. So maybe we call it wins. And then this can be the what would be a good name for that? Like the, what is it in part 1? Points. So we have now 2 functions called wins and points. So this is wins, and this is points. $23,235. Was that the right answer? Yep. Okay. Let's try this one. That's right. We got it. Okay. That's day 4 solved. I just want to run through it really quick. Again, I really like to read through my code one more time and make sure it's all really sane. I honestly don't mind doing it this way. Some people like to do the bracket for this entire thing. But I don't mind it looking like this. So our card will have the list of winners and what our numbers were. And then to calculate part 1 points, we do this. Is there a way to do this without an if block? So if the number of wins is 0, we return 0. What is 1 to the... It's just 1, right? Yeah. Which is not the correct answer. We want 0 wins. But for some reason, it's not coming to my mind. Maybe I'm just tired of how we could simplify that if block. Because, I mean, this function is right. It's just the intersection of the two. Points is this. Okay. Yeah, I think I'll just leave this for now. There might be some other way to do this. Anyway, okay. So parse set. We've already kind of gone over the parsing, so I feel pretty comfortable with those. But again, I've probably said this half a dozen times now. If you know more about nom than I do, I would love to hear your input on it. I do not have time today. I'm running out of time, so I won't be able to do it. But this feels relatively easy to solve in Rust, right? This is a very functional approach to this. And this is even somewhat functional because you could iterate recursively in the thing or in this list, right? You just like iterate through the list and increment values as you go down. So that's plausible too. Maybe as I have time, this will be a good candidate to do in Haskell as well. Did I say Rust? Do in Haskell. But anyway, that's my solution. Again, I'd love to hear input on what you guys think. What could I improve? What would make the code look cleaner? Maybe I'll add some comments after the fact. But then, yeah, I'd love to see what you guys did as well. So send me your things. I know it's hard to do that in the YouTube comments, but if you can describe it or find some way to get it to me, that would be cool. Maybe that's what I should do, is find some way for... I try and post this to Reddit too, so you guys can just share your solutions under mine, so I can see how you did it, or tag me in your solutions or something, some way for me to see your solution. I'd definitely like to see it, especially if you're looking at mine and want to do comparisons. Okay, talk to you later.